What's the derivative of the Lambert W function? Well, let's find out. But before starting differentiating this function, we first have to know what the Lambert W function is. In fact, given the function f of x equals x times e to the x, the Lambert W function w of x is defined as being the inverse function of this function x times e to the x. So the inverse function of x times e to the x is defined as being the Lambert W function of x. So we can now use this to differentiate the Lambert W function. So given the function y equals w of x, we can find its derivative using implicit differentiation. So what can we do? We apply its inverse to both members, and this is what we get. X equals to y times e to the y. Now, this is where implicit differentiation comes into play. In fact, we can just differentiate both members. So let's go ahead and differentiate both members. So d over dx of x equals d over dx of y times e to the y. Now, d over dx of x is trivial, it is just 1, and 1 equals to d over dx of y times e to the y. And to find the derivative of the right-hand side, we have y times e to the y. We can simply use the product rule. So let's do it. We have dy over dx, because it is d over dx of y, times the function e to the y. Then plus the derivative of e to the y. So let's write down d over dx of our function e to the y times y, and now dy over dx is times e to the y is just dy over dx times e to the y, plus what is now the derivative with respect to x of e to the y? Well, we can use the chain rule to find this. So this is just d over dy of e to the y, that is e to the y. So e to the y times the derivative of y, because this is the chain rule. So dy over dx times y. And now let's rewrite our equation. So we have that 1 equals to dy over dx times e to the y plus dy over dx times e to the y times y. Now we are interested in dy over dx because it is the derivative of the Lambert W function what we are trying to find. So we can just factor out dy over dx. So let's do it. We can factor out dy over dx like this. Dy over dx times e to the y plus e to the y times I, and this equals 1. But we haven't finished yet. Let me clear the blackboard and we will continue to find this derivative. Okay guys, so now what can we do to find dy over dx? Well, just divide both members by e to the y plus e to the y times y. So let's do it. We have our dy over dx, what we're interested in, equals to 1 over e to the y plus e to the y times y. But we want this derivative as a function of x, not as a function of y. But what was y equal to? Well, y was equal to our function w of x. So let's just replace y with w of x. So d over dx, or sorry, dy over dx equals to 1 over e to the y is e to the w of x plus e to the y is again e to the w of x times y, that is w of x. But now remember that the function w of x, y equals w of x, is the inverse function. So f of x equals w of x is the inverse function of x times e to the x. And whenever we have a function and its inverse like this, so f of, sorry, this is not prime, this is -1, it means that it is its inverse function, while prime means its derivative. So whenever we have a function of the inverse function, this gives us x, and whenever we have the inverse function of the function, this is just x. In other words, if we replace in this equation right here, we just replace x with w of x, we have that w of x times e to the w of x, this is simply equal to x. So now, using this identity, we know that all this part right here is simply x, and we can even rewrite e to the w of x in a simpler way. And how can we do it? Well, just divide both members of the equation by w of x to get what e to the w of x is equal to. This is so simple. E to the w of x equals to x divided by w of x. And using these two equations, we can rewrite our derivative as dy over dx is equal to 1 divided by e to the w of x is just x divided by the Lambert function of x plus e to the w of x times w of x. Well, this is so simple, this is just x. But we haven't finished yet, because we can do another things to get things simpler. In fact, we can just multiply and divide the equation by w of x in this way. So this equals to w of x times x over w of x is just x. Then we have x times w of x is x times w of x. And at the numerator, we just get w of x. And this is our final answer. This is the derivative of the Lambert W function of x. It is just w of x over x plus x w of x. How cool is this? This function is very interesting, and I thought it would be interesting to find the derivative of this function. This is not something too abstract. We use this function whenever we have to solve equations where there is x times e to the x or something like that. Like we use the natural log function to solve some exponential equations. So if you enjoyed this video, leave a thumbs up, share it with your friends, don't forget to subscribe to my channel, and leave a comment below and let me know what videos would you like to see in the future. And as always, until next time, bye!